Okay, so the first class for integration of AS and the last topic for AS for P1. So hopefully we will be completing this in 3 4 classes, maximum 4 classes with the past papers. And okay, first of all, integration. Another name of this integration is also called, it's also an anti-differentiation, because as I told you in the last previous classes as well, that differentiation and integration, they come in hand to hand. They are a part of calculus. Overall, we call them calculus, but they are very much related to each other. So we have initially, let's suppose we have the y function or the fx function. When we differentiate this, we get the first derivative, the f dash or the dy by dx. This is what we get when we differentiate this. But if we want to get back to our original function again, if we want to reverse this effect, we integrate it. So this is what is actually integration. So the first application that you now understand is simply, the first application is getting your original function, getting your function back from dy by dx, or from the double derivatives as well, or the double derivative as well, d square y upon dx square, by integrating it twice. If it is your first derivative, you would integrate it once and you will get the original function. And if it is double derivative, we would, if we would have to integrate it once, we will get the first derivative. Then we would integrate it again, we will get the original function back again. So this is the first thing that you will learn. Then there are another more things as well to this. So it's not very big, but we will see this. But this is the first thing that we will do. But even before inputting this, using this the application, we have to learn how to integrate, just like we did how to differentiate. So over here, what do we have? The formula, or how do we integrate. The first one, first of all, this is the sign of integral. You will see something like this. There's not a bracket. A bracket is something like this. This goes in and then goes the other way. So this is the sign or the notation used, that will tell you that you have to integrate, that we are trying to integrate this, and whatever the function is, it will be written over here and then dx. So this means that you are going to integrate the inside this bracket, whatever is inside the bracket, with respect to x. So integrating with respect to x. This is what it actually means. And now the first formula is that if you have the integral x power n, the same way we had over there as well, differentiation x power n, derivative of x power n. Over there, what we did was that we brought the power down, the power came down and multiplied, and power was reduced by 1. But now over here, it is absolutely opposite. First of all, we add the power n plus 1. First, we add the power and then we divide the new power n plus 1. And then another thing is, we also put in, whenever you do the integration, we also put in the value, the constant c. This constant is called the constant of integration, integral. And this is, you have to write this down. Whenever you different integrate this, you put in the plus c as well. This is, you can say, part of the formula. After you integrate all of the terms in the equation, you put in plus c as well. I will tell you why do you put this plus c later on. But right now you have to understand this is something that you need to show. So for example, if you have the integral of x power 2 dx, or if you have the integral of square root x, or if you have the integral of minus 6x minus 4. So how would you integrate this? First of all, simple. What do we do? The x power adds by 1, 2 plus 1 divided by the new power 2 plus 1 plus c. So this becomes x cube upon 3 plus c. This is it. Simple. Over here, this is x power square root. Square root x means x power zero point 0.5. And then this would become x power zero point 0.5 plus 1 divided by zero point 0.5 plus 1 plus c. And then what would you get? X power 1.5 upon 1.5 plus c. If you want to simplify this thing further, 1 divided by 1.5 will give you 2 upon 3. So you can even write it down 2 upon 3 x power 1.5 plus c. But this is the integral answer. This is just further simplification. This is your integral, and the rest of it was a simplification. Then the last one, minus 6. Just like in differentiation as well, the coefficient was just there. You just multiply the power if it comes down and divide. Over here as well, this minus 6, you can even bring this out. You can write this coefficient outside the integral, minus 6 x power minus 4 dx. And then this would become minus 6 still outside, x power minus 4 plus 1 divided by minus 4 plus 1. So this will become minus 6 x power minus 3 upon minus 3. Minus minus cancel out, 3 times 1, 3 times 2. So this becomes 2x power minus 3 plus c. This is your answer. This is the basic thing that you have to learn. First of all, how to integrate, and then we would move on to how to further apply this integration. Another formula or thing you need to learn is, if let's suppose there is an integral of a constant, integral of constant a, it can be anything. A can be 100 or minus 4 or 6 or million, any constant. So in differentiation, what happened was, when you differentiate a constant, the constant would disappear. It would become zero. Over here, it won't disappear. It will get the variable. So this would become ax plus c, because this is the opposite. In the differentiation, your constant was getting removed. It was getting eliminated. Became zero. Over here, the integral of a constant is that now the constant will get a variable as well. It would become ax. So let's suppose now, if you have example, integral of 4x cube minus 6x minus 4 dx. So this would become, 4 is the coefficient, 4 would remain as it is. X power 3 plus 1 would become 4 divided by the new power 4 minus 6. X power 1 plus 1 will be 2 divided by 2, and then minus, this is a constant. I told you, when you integrate a constant, it would get the variable. So minus 4x and then plus c. If you simplify this thing, so x power 4 minus 3x square minus 4x plus c. This is your answer. This is the answer to the integral. Sometimes you may also need to simplify your equation before you start integrating. Okay, sometimes your equation won't be as simple. Let's suppose it is something like this. Integral of x square minus 7 upon under root x. Now in this one, you cannot directly start integrating. You won't be able to. So first you will have to simplify, use a bit of indices, and separate the terms before you get it in this format. Separate terms, and then that would become easier for you to integrate. So in this case, what it would become, in order to simplify this thing, you can do x square upon under root x minus 7 upon under root x. You separated the fraction, so this would become x power 2 minus 0.5, and use indices. You know how to do this. 2 minus 0.5 will be 1.5 minus 7 x power negative 0.5 dx. And now you're going to start integrating. So x power 1.5 will become, add plus 1 to the power 1.5 will become 2.5 divided by 2.5. Then minus 7 x power negative zero point 0.5 plus 1 will be positive 0.5 divided by positive 0.5 plus c. And if you want to simplify this thing further, you will get 1 upon 2.5 will be 2 upon 5 x power 2.5 minus 14 x power zero point 0.5 plus c. This is your answer. Okay? Any questions, anyone?
नो सर।
Munib,
सर
Sanjay?
इसमें लिमिट्स
Last,
कहाँ पे डालनी होती हैं?
Go later on when they ask you to find the area. That is another application.
ओके ओके ओके।
So
sir,
first,
last fraction वाला दोबारा explain कर दें.
last fraction. Sometimes I'm telling you that the equation won't be as simple. It can be something like this as well, or even more complicated than this. So before you start integrating, you use simple indices, you move things around, and you separate the terms before you start integrating. Because the rule of integration, look, it applies on a separate terms is x power something. So if it is in this format in a bracket, something like this, and you have a denominator as well, so you cannot directly apply x power 3 upon 3 on this thing, and this would become 7x, and this would become x power 1.5 upon 1.5. You cannot do this like this. So you what do? You first use a bit of indices, you separate the fractions, you simplify the powers, and then you start integrating. So what did I do? So I separate this x square upon this under root x. It is in the denominator of both of these. So first of all, x square upon under root x, I separated this thing, and minus and 7 upon under root x. You can see both of the denominators are same. So I can go back to the same step again. Back the denominators are same, so I can combine the fraction. So if the fraction is the same, I can separate it into the same denominators as well. And then I use indices. This x power zero point 0.5, x power 2. When they're dividing, we know the power subtract. So 2 minus zero point 0.5 will become 1.5. And this is x power zero point 0.5. If I move it upwards, it would become negative zero point 0.5. So 7x power negative zero point 0.5. And now you can see these are in separate terms now, x to the power of n, something like that. So the power adds by 1 and then divided by the new power. So 1.5 plus 1 will be 2.5 and divided by this new power 2.5. Minus zero point 0.5 plus 1 will be zero point 0.5 divided by the new power zero point 0.5. And then I have just simplified it. This is your integral. If you want to simplify, you can simplify this further, but this is what they had asked you to find, the integral. Okay? Okay. One more example. There's a third formula as well for integration. But before moving on, let's clear this. If you have integral 2x cube minus 5x plus 1 dx. Now, this is also the basic one, not very difficult. The 2 is a coefficient, it remains there. X power adds by 1, 3 becomes 4, and divided by the new power, 4, minus 5, x power 1, 1 plus 1 is 2, upon 2 new power, plus 1 is a constant, so it will get the variable x. So 1 this would become 1x, then plus c. If you want to simplify, this would become x 4 upon 2 minus 5 upon 2, sorry, 5 upon 2 x square plus x plus c. This is your answer. And now the last formula to learn for integration. If you have integral of a bracket raised to the power n, in fact, it can be anything inside the bracket. Whatever is inside the bracket, doesn't matter. You will do it the same way. So if the bracket is raised to the power, it can the inside of the bracket is a function of x. Okay, it's something with x. So how do you integrate this? what happens? First of all, no changes inside the bracket. Whatever is inside the bracket will remain inside the bracket same as it is. The power of the bracket increases by 1 plus 1 divided by the new power and plus 1. And one more thing is that you will also write the derivative of the inside of the bracket in the denominator and then plus c. So you will differentiate the inside of the bracket and you will put it in the denominator. Now, for example, you have integral of 4x plus 3 power 5. So look at the formula which I've written down, and I'm just going to follow the steps from the formula. So no changes to the bracket whatsoever. 4x plus 3 doesn't change. 4x plus 3 is there. And the power of the bracket increases by 1. So this would become 6. 5 becomes 6. Divided by the new power 6. And now the derivative of the inside of the bracket. The derivative of 4x plus 3. The derivative of 4x plus 3 is simply 4. That also comes in the denominator. And then plus c. This is your answer. If you want to simplify, 4x plus 3 power 6 upon 24 plus c. This is your answer. This is the integral. Let's do another example. If you have, let's suppose, under square root 2x plus 1. So first of all, two the square root means power 0.5. And now no changes to the bracket, to the inside of the bracket. The power of the bracket adds by 1. So zero point 0.5 becomes 1.5 divided by 1.5. And the derivative of the inside of the bracket, 2x plus 1, that is derivative of 2x plus 1 is 2. So 2 comes in the denominator plus c. This is your answer. Let's suppose you have 1 upon 5x plus 3 square dx. They're asking you to integrate this thing. So first you would move the bracket above. So this would become 5x plus 3 power minus 2 dx. And now the exact same thing. No changes to the inside of the bracket for 5x plus 3, 5x plus 3. Same. Minus 2 plus 1 will become minus 1 divided by minus 1. And the derivative of the inside, 5x plus 3, will be 5 plus c. This is your last and final integration rule that you need to learn. Okay. Now the first application of using integration. Find the equation of the curve through 1 comma 2 for which dy by dx is given to you under root 2x plus 1. Simple question. And a very past paper. You will get very similar questions in the past papers as well. So they have given you the dy by dx. Sorry. It is 2x plus 1 power 0.5. And they've given you a point through which this curve is passing through. Why have they given you a point of? So that we can find the value of c. To find c, this is the condition they have given it to us. Whenever you do the integration right now, if you would integrate this, you want to get the original function back. I told you, if you want to go back to the original function, you would integrate this. So when you integrate, you will get y is equals to the integral of this 2x plus 1 power 0.5. So you would do it the usual way. What would happen? The bracket will not change. This would become 1.5 divided by 1.5 multiplied by the derivative of the inside of the bracket, which is 2, plus c. Right now, because you don't know the value of c, this equation is incomplete. When you just find the integral till here, you call it the general solution. This is the general solution, not the specific solution, okay? Not the particular solution, because this is still incomplete. The value of c will change the equation, will change the graph. If your c value is 4, it will be a different curve. If your c value is 7, it will be a different curve. It will be not about transformation, right? It will go up and down because of this value of c. So this graph is still not the exact graph that they are talking about. Now using this point, we know we would substitute this point into this thing, and then we will find the value of c, and then we will get the particular graph, the particular equation that they are asking you to find. So now if x is, we know if x is 1, your y is 2, and if we substitute, we will get the value of c. Find the value of c. So this would become y is 2, x is 1. So 2 times 1 plus 1 power 1.5 upon 1.5 times 2 is 3, plus c. You can use your calculator. This becomes 2 plus 1 is 3, 3 power 1.5 upon 3. So under root 3. So your c comes out as 2 minus under root 3. This is the answer of your c, and now you would replace this in the original function, in the integration that you have found. 2x plus 1 power 1.5 upon 3 plus 2 minus root 3. This you have replaced the value of c. This is the exact solution. This is the particular solution. You will call this the particular solution. And this is a very past paper like question. And this is all how always you will do this. Integrate it and then use the point that they have given you to find the value of c. And then replace the value of c in its place. Okay, look at this. The part A, B, A, C, and D, they are not of a concern, that is differentiation. The second part B, is the thing we need to do. They have given you, look, they have given you the double derivative. The double derivative is 6x squared, and if we move the x cube above, this would become 4x power minus 3. And they have given you that this is a stationary point. And you know, a stationary point is where your single derivative value, the dy by dx, it is equals to 0. From differentiation, if you can recall, at the stationary point, at the turning point, at the minimum maximum point, your derivative, first derivative, is equals to 0. In the first part, they're just asking you to find the nature of stationary point, so you would just substitute the value of x, the x value of the stationary point, in the double derivative, and see if it is positive, negative. If it is positive, you will say it is minimum. If it is negative, you will say it is maximum. So that part, the first part, is also of differentiation. The second part is of concern right now. Find the equation of the curve. So we have the double derivative, so this means we will have to integrate it twice. So if I would integrate it once, I will get the single derivative. I am integrating it once. 6x square minus 4x minus 3 and dx. Sorry, dx. I will get the first derivative. So integrate the usual way. This would become 6x power 3 upon 3. Power adds by 1 divided by the new power. Minus 4x power minus 2 upon minus 2. Plus c. This is your single derivative. If you simplify, this would become 2x cubed plus 2x minus 2 plus c. How will you get the value of c, this value of c, before we try to integrate again? You will have to find the c. Anyone? How will you get the c?
Substitute the stationary points in x and y.
Stationary point, you have the value of, yes, that we are very close, but slightly wrong. We know, good, that's good. The value of the derivative, it will be 0 when your x value is, you can see, minus 1. We don't have the y coordinate over here to put in. We know that the value of the first derivative, it will be 0 when a value of x will be the turning point x, which is minus 1. And that is how you can find the value of this first c. We know that dy by dx, the first derivative is 0 when x is minus 1. So we can use this condition and find the value of c. So this would become minus 2 and plus 2. So c is 0. So that is easier. So the first derivative we have found, it is 2x cube plus 2x minus 2 plus 0. And now you will have to integrate it again. If you will integrate it now again, you will get the original function back. And you would do the integration the usual way. 2x 4 upon 4 plus 2x minus 1 upon minus 1 plus c. Simplify, x 4 upon 2 minus 2 upon x plus c. And now to find the value of c, this value of c, this, let's suppose this is c1, this is your c2. Whenever you would integrate, your c, your plus c would come in, okay? Whenever you would integrate. So don't forget this. Now you have the x value, we know that x value is minus 1 on this curve, and the value of y is 9 upon 2. And now we can get the value of c2 as well. So 9 upon 2 is equals to minus 1 power 4 upon 2 minus 2 upon minus 1 plus c2. So 9 upon 2, 1 upon 2 plus 2 plus c2. 9 upon 2 minus 1 upon 2, 8 upon 2, 4. क्या हो गया? 4 minus 2 is 2. So c2 is 2. This means that your original function back, it is x 4 upon 2 minus 2 upon x plus 2. This is the answer. 5 marks. Look. Okay. Let's find another question similar. Question number 8. A curve is such that dy by dx is given to you. 8, and if I bring the bracket above, this would become 3x plus 2 power minus 2. The curve passes through point 2 comma 5 whole 2 upon 3. Okay. So look, they have given you a point as well through the curve so that you can get the value of c. So if you integrate this, so y will be equal to 8 bracket 3x plus 2 power minus 2 integral. So this would become 8 is the coefficient. So 8 will still be 8. The inside of the bracket doesn't change. 3x plus 2 remains 3x plus 2. Power adds by 1. So minus 2 becomes minus 1 divided by minus 1 and multiplied by the derivative of the 3x plus 2, which is 3 only, and then plus c. So now you simplify. 8 minus 8 upon 3, 3x plus 2 power minus 1 plus c. And now the point that is given to you to find value of c. 5 whole 2 upon 3 is equals to minus 8 upon 3, and 3 times 2 plus 2 power minus 1 plus c. So 5 whole 3 upon 2 upon 3 will become 17 upon 3 plus 8 upon 3, and this would become 6 plus 2 is 8 power minus 1 is equals to c. You can use your calculator to simplify. Make your life easier. 17 upon 3 plus 8 upon 3 multiplied by 8 power minus 1. 6. And now you would replace it. So y is equals to minus 8 upon 3, 3x plus 2 power minus 1 plus 6. This is your answer final. This is it. 4 marks. Easy 4 marks. ठीक है, I'm stopping the recording. You can copy this down.